everybody, welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over another one of our geometry topics. This topic is the distance between a line and a point. So they're always going to give you a line, they're going to give you a point, and they're going to ask the distance between the two of them, just like the title says. So as always, it's important that we know our steps. So we're going to start with our steps. Step one is to find the equation perpendicular to the line given through that given point. So we're trying to find where it's going to cross perpendicularly. So we have our point, we have our line. We are going to find the perpendicular equation through that point to be able to see where it crosses. Then we're going to set the two equations equal to each other. So we're going to take our original equation that they gave us and our perpendicular equation, and we're going to set them equal to each other to see where those two lines intersect. Once we find our x, we're going to solve for our y because we have to complete the points. We found our x, find our y to be able to continue with that point. So now we have the point where our perpendicular lines intersect, and we have the point that they gave us. We have like one point here, let's say, and one point here. We're going to use those 2 points to find the distance. So if we have a line, we have a point, well, that point where they intersect is on that line. So if we could find the distance between the point they gave us and the new point that we found, we're finding how far that line is from our original point. So we're going to use our distance formula with our new point and our original point to find how far that line and that point are from each other. Of course, this sounds like a lot, so let's take a look at an example problem to make sure we're understanding what I'm saying. So for this example problem, we want to find the distance between line R with the equation y equals negative 1/2 x plus 3, and the point A, which is 6, negative 9/2. So they give us our line, they give us our point, and now we have to continue with our steps. So our first step is to find the perpendicular line that's going to go through that point. So our perpendicular line, we have to remember, they give us a slope of negative 1/2. The perpendicular slope to that is the negative reciprocal. So we flip the fraction and change the sign. So we flip it, so it's become 2. And then that negative becomes positive. So our new slope is going to be 2. So we get y equals 2x plus b. Now, we want to find what that b is. We need to find our y-intercept. So I'm going to use the point that they gave us because we have to go through that point. So I'm going to plug in my y as negative 9/2 and my x as 6. 6 times 2 gives me 12, so I have negative 9/2 equals 12 plus b. We know that 12 is 24 over 2, so I'm going to subtract that over. I'm just going to use my calculator just in case. And I get negative 33/2. So this is the same thing as if I subtracted 12 over 24/2, just so I can see to commonly combine them with the same denominator. So this becomes negative 33/2 as my b. So my perpendicular equation now is going to be y equals 2x minus 33/2. So this is what I'm going to be using to continue the problem. I'm going to erase the rest of this, so make sure if you're following along, you understand it. Pause it if you have to. So once I get my new equation, the next step was to set these two equal to each other to solve for our x. We want to see where these two intersect, so I can use that new point to find the distance with my original point. So I'm going to have negative 1/2 x plus 3 equals 2x minus 33/2. We're basically doing a systems of equations. And why are we allowed to do this, you may ask? Because we're saying that y equals this and y equals this as well. So using our transitive property that we've seen this year, if one thing equals y and another thing equals y, they both equal each other. So the transitive property of equality tells me I can set them equal to each other. And now I'm going to use my algebra techniques to solve for x. So I'm going to subtract 2x over, and I get negative 5/2 x plus 3 equals negative 33/2. I'm going to use the common denominator again. If I subtract 3 over, that's the same thing as subtracting 6/2. So I get negative 5/2 equals negative 39/2. I have that x attached to it. We know that this, when I divide by negative 5/2, that's the same thing as multiplying by negative 2/5. And when I do that, it cancels out on the side, and I get x equals, these two will cancel out, the negatives will cancel out, 39/5. And I really like working with decimals for this. Usually I'm not a huge fan of decimals, but when we're trying at the end to use the distance formula, it makes sense just to have it in decimal form to make our lives a little bit easier. So 39 divided by 5 gives me 7.8. So my x value is 7.8. Once I find my x, I'm going to plug it into one of these equations. I'm going to check both just to make sure I'm correct. But either of these equations, they both should give us the same answer, seeing that they're equal to each other. So I have to do 7.8 times -1/2, and then add 3. And that one gives me my y as -0.9. So I plugged in 7.8. So I did 7.8 times -1/2, which is the same thing as -0.5. I added 3, and I got -0.9. Let's do the same thing over here just to make sure. 2 times 7.8, and then I subtracted 33 divided by 2 from that, and I got -0.9 as well. So that has to be my point where I did something wrong. So my new point is going to be 7.8, comma, -0.9. So this is where my perpendicular line and my original line intersect. So now I have a point on my original line that I can use to find the distance between that point and our original point to be able to find the distance between the line and the point. So I have this new point. I have my original point here. I'm going to use the distance formula. The distance formula is the square root of x. So I have 7.8 minus my other x squared plus my y. If I use this x, then this x, I have to use this y, then this y. So my y minus a negative becomes a plus 9/2 squared. So 7.8 minus 6 gives me 1.8 squared plus -0.9 plus 9 divided by 2 gives me 3.6 squared. Even if this was a negative on the inside, when we square a negative, it becomes a positive. So it should always be a positive on the inside. So 1.8 squared gives me 3.24 plus 3.6 squared gives me 12.96. So I'm just using my distance formula and plugging in. Distance formula tells me to be x2 minus x1 plus y2 minus y1. Each of those terms squared, and then add them together. So I'm going to add my two final answers there, and I get the square root of 16.2. And if I square root that, that's approximately 4.02. So the distance between my line and that point is going to be approximately 4.02. And I can draw a diagram. Let's say this is -1/2 x plus 3. Let's say that looks like this. And then 6, -9/2 is like, let's say, over here. And we want to find the distance between the two of them. I found my perpendicular equation, and that's going through here. It's going through my points, going through my original line, and I found where they intersected. They intersected at this point here. I drew the point. Now we find the distance between these points to be able to see how far this line is from that point. So obviously this is just a rough sketch. It's not exact, but I wanted to give you a visual on why we do this. Why do I need to find that perpendicular line? So it cuts through my original points. I find where they intersect to be able to find the distance. If I find the distance between these 2 points, that's the distance between my original line and my new point. So I hope this was clear. Make sure you follow the steps every time you try to do these problems, and thank you for watching.